Hello everyone. Thanks for coming. Good afternoon. And my presentation will be, as said, about the deployment and management of Ceph with Salt, or Project DeepSea. My name is Joshua. I work out of Germany, Nuremberg, at our headquarters. I'm a software engineer for now 5 years at SUSE. And I work full-time on the deployment and management framework called DeepSea. So, what is DeepSea? DeepSea is basically an accumulation of Python modules, salt files, state files, salt orchestrations. I'll come to that in a second, what it actually means for us, and which are meant to manage Ceph at scale. So the project itself was started by SUSE at SUSE, and it had in mind to make the deployment of Ceph very easy and also scalable and also customizable. There are also lots of management tasks that you will have after the deployment, and we also try to take care of them. So I said that we built our product on top of Salt. So you might not know Salt. So Salt is a open source configuration management tool, which is also a remote execution engine. And you can do the infrastructure as code approach. And it generally competes with things like Ansible, Puppet, Ceph. You might know those kind of software. It is 6 years old by now. It has a minion and master architecture. I will come to that, so that helps with the concurrency. And it's based on the 0MQ messaging transport protocol. And it's also highly scalable and extensible, so that allows us to actually write our modules in Python on top of that. So we all heard by now what Ceph is and what it consists of. So just to get the basic assertion straight, we have basically a cluster which consists of nodes, and all these nodes have or can have one or multiple roles. And so typically one of them is like an OSD, one is a manager, one is a monitor, and they can have, of course, different kind of roles. Of course, they have also different kind of requirements and or restrictions, and they also need to be configured. That's the deployment part, and they also need to be managed as a post-deployment task. So, how does it actually work? As I told you before, we have now the minion and master architecture, and you can issue out here a command, for example this here. So we will demystify it, so that asterisk says just target everything, and that's just the call that you make to the cluster. And that's being issued out by the master to the minions, and here you see it sends a command and the minion returns it. And here it's also important to mention that it's, as in the most configuration management systems, it's not actually really, so you can do that regardless of the underlying operating system. So they can be either a Solaris, a Linux, a Windows, a OS X, FreeBSD, whatever, so that doesn't matter. And you also have to understand that there is this disk part here is actually a Python file, and the usage one is a method within it. So that allows us to provide or write our own modules that helps us to write, to deploy and manage Ceph. And so I also mentioned infrastructure as code. So you could theoretically write something like that, right? If your disk usage on all your servers is below 100 gigabyte, do something. But that doesn't work like that. It is more, so salt structures salt structures that in a so-called salt state file, short for SLS. And it looks like that. So that's the Jinja syntax, and you have to define an ID which must be unique, so that it can be identified internally. And then you can specify which kind of module you want to invoke. You can give it a name, and you can also pass arguments. So you have to pass arguments, of course, because when you have multiple disks, as an example, at the disk usage, you can pass any disk and it will return you the information. So that allows you actually to condense multiple modules within like one file, so that when you call now your state, you can actually call multiple different kind of methods within it. And so the syntax that we now have slightly changes. Here on the bottom you can see it. It's actually now a state which you apply, and then it's your state that you just defined. So I just said that it can be extended with Jinja. So these state files can be extended with Jinja. So Jinja is a templating engine which can inject data at runtime into your SLS files so that they can be dynamic and that you can basically react to your environment. But there are some questions, of course, which I'll answer in a second. One of them is, where do these values come from? How do we actually store the data? And where do we get this information about nodes and all that? So there are two key principles that we get from SALT. This is not something that we invented. This also comes from SALT. First one is the grains, which is dynamic information that is being stored on the minions, as you can see here. That is typically something like what kernel am I running, what kind of SALT version am I running. There are, I think, 50 different kinds of information that can be retrieved from these grains. And those live on the minions, that's important to know. And the second part is pillar data, which is static and user-defined data that lives in the master. And you can modify that, and you can enter whatever data you want to have. So for example, we store the Ceph cluster FSID, we store roles data, and so on and so forth. But I will come to that, and we will see how we use it in order to make things work. But first, let's recap, because it was some kind of a lot of information right now. So we need to map roles to certain nodes in order to meet our requirements, and we have grains that provide us information about different nodes, and that also allow us to check the requirements. You know, if we have the correct kernel running and stuff like that, we can provide now user data by the pillar. We can now execute commands and can execute them on different kind of nodes. We can target them, and we have states where we can logically group lots of different functions that we can write ourselves. So we now have a pretty good toolbox. But now, you know, when you come to the preparation phase and you enter your data center and you want to build a really, really huge cluster with like 2,500 nodes, and the only information is host names. How do you actually map any type of host name to a certain role? So the short answer is you can write that in the pillar, because that's static data that's provided by the user. The long answer is that we came up with a file that we call the policy.cfg, and what that does is we try to write a directory structure. You can see here, so that's a directory structure called role minus master, role minus admin, IGW, and so on and so forth. And under that, we write a file. So every host name is represented as a file within that directory. And what that allows you then is to glob or do slicing, or just do a selection of different kind of files which are represented as host names. And so when that is evaluated by Python, it can actually give you a dictionary which represents then roles mapped to the host names. So that's kind of neat. And you can do For example, here also like fancier things like slicing, so that would, for example, select always the last one. So currently we have in our cluster 4 nodes, which is node 1, node 2, node 3, node 4. And that one then would resolve to node 4. We can also do regexing when you have a more sophisticated setup as a host name. You can do all certain fun stuff that you can do with regex. In our current example, we would now, so that if you now have a look at node 1, this would then be the role master, role admin, not role IGW. It would be a monitor, it would not be an MDS, and it would have a manager. So if we then check that, because we can also query for it, it returns a structure and then it will give you the name of the roles. So that now gives us one more feature that we can actually use. So we can now abstract the target here, so we don't have to care about host names anymore. We can write query instead of providing an actual static host name. You can write query the pillar and give me everything that has these key value pair of roles and mon, and apply a state on it. So that allows us to not think about host names anymore, but to think about in a more abstracted way, and that's more scalable. So in theory, we now have everything. So we could now target every role and do our validation first, do our configuration, do our deployment, and do that for every single other role and management, and that's not quite how it should be. So luckily there is one last feature, one last thing that we have to understand in Salt, and that's the so-called orchestrations. And these orchestrations do the same thing as states. So states condense different modules, and orchestrations condense different states. So that allows us to have that kind of syntax, and you realize there is no targeting anymore. So this targeting is actually in a file that can be parsed with Jinja. So you can extract everything out of the pillar, which we have the information in which kind of host maps to which role, and then we can here write a custom orchestration which holds lots of different states. And these states can be a validation, a configuration, and a deployment and a maintenance. And voila, you have basically everything that you need to deploy a cluster. So with this kind of toolbox, we came up with a concept that makes it very easy to deploy a cluster. That is basically, you go through different steps, or as we call it, stages 0 to 5, so 6 in number. And those, when you walk through these stages, you will after it have a running Ceph cluster. So stage 0 is your pre-deployment stuff. It patches your cluster, it syncs the modules, it updates it. The stage 1, it gathers information about your cluster, and then it writes the kind of directory structure that I mentioned before. And the second one writes then the pillar data to the pillar, and this is where you also change your policy CFG to your needs. And there is the third stage, which actually does all the deployment for you. And you can see that this is just one of these commands. So you write salt run stage orchestration, and then ceph.stage.1, 2, 3, and then that's good. And then we also divided it into 4 and 5. And if we now have a look again, so this is important to understand, that this orchestration holds different states in it. For example, one state is this, one state is this, one state is this, and that state has a module in it, and that module calls either apt or zipper or yum or DNF based on its grain. So that's cool. Cool. And we have also different features that we implemented. So we not only do the pure deployment and management, we can also do, for example, a file store to BlueStore migration. So when you have a cluster deployed with file store and want to switch over to BlueStore, you can do that online and live with our feature. That you can even decide if you want to do the migration on an OSD level or on a node level, depending on your needs. You can do baseline benchmarking before you even want to deploy it. So, for example, if you buy hardware and you want to test it, if you want to get the numbers before you actually deploy something, or then you know if you want to buy some new switches or better SSDs, NVMEs, and stuff. Although it was started at SUSE in the beginning, was only supporting SLAS and OpenSUSE, we also got a contribution that we now also support CentOS. And we kind of support Ubuntu, but it's in a work in progress state. But we really welcome contributions to get this extended. What we also have is we have automated restart. So that means that when you patch your cluster, which is part of stage 0, so you can run that, and when there is an update which leaves a deleted file behind or a config change, then this affected service, like an OSD, will be restarted, and only if there is a file deleted. And also the same thing if you do a configuration change that affects your ceph.conf, there will be retracted with checksums, so there will be a restart. And the restart will not affect your uptime. It will do it one by one by one by one, and it will check in between if your cluster is still running. The same is for updates and upgrades. It will do it one by one, check in between if there was a failure. If there was no failure and everything is okay, you have a health okay, it will move on. And it will not be okay, it will not move on and bail out and just fail and leave you with the operations that you need to do. So, that was the theory. I also have a demo because all the theory is boring, and you can see that. It's a pre-recorded demo, I don't do it live, sorry. And I also sped that up ×4, because I don't know how much time do I have left. Not too much, I think. So we start with not having a Ceph cluster, and then we run DeepSea to stage 0. And this really reflects, and you can see here, I hope you can see that, I think. It does patching, it does syncing, updates, it does the restarts, then we rerun stage 1, sorry. It does pre-validations, it determines your network interfaces, it generates your proposals, it creates all these directory structures. Then at that point, you would, in theory, customize your policy CFG, but in this example, we just copied over because it was a predefined one, and it's faster, it's easier. Did I hit the start button again? Yes. Keys are created. Oh, we have also monitoring based on Grafana and Prometheus. So that's default right now. Currently, this will be deployed on every node, at least the node exporters. That will be changed in their later releases so that you have a separate role for monitoring, that you can really only enable it and disable it on certain hosts. And then there is the deployment phase, which is actually for having just a really, really basic cluster, already the last one. And so now only the packages will be installed, and monitors will be configured, managers will be configured. And we're done. And there we go. As we can see, we have now a up and running Ceph cluster. This is, of course, times 4 the speed, but you can see it. It really doesn't matter if it's like 1 node, if it's 50 nodes, if it's 100 nodes, it just doesn't matter because you have the thing of a policy CFG which allows you to map host names to roles, and then you don't need to care how many nodes you actually have. So that's a core feature of it. And with that, I'm at the end, and I want to thank you for your attention. And down here you can see our GitHub project. Below that is my account. And now we have a couple of minutes for questions, if there are any.
Any questions?
Yes, please.
Do you have some plan to add some user interface on that?
A user interface in the sense of user interfacing this one, actually yes and no. So we ship currently OpenAttic with it, and OpenAttic can do some of these operations, but that is currently only console-based, and there is no plan yet to make an UI for it.
Okay, thank you.
Yes.